The era of bigger is better has hit a structural brick wall. Organizations are burning millions in API costs for reasoning tasks that do not require a 100 billion parameter monster. Imagine your production stalled by latency because you're using a frontier model for every basic logic gate. This is the scale myth. Enter VibeThinker 3B. By leveraging curated SFT and the breakthrough group Relative Policy Optimization, or GRPO, this 3B model matches reasoning benchmarks of what we once considered opus-level territory. We are seeing specialized small models outperform giants in logical consistency and mathematical proofing. This shift isn't just about compression, it's a reimagining of training for depth over breadth. If your current strategy relies solely on massive cloud models, you are architecting a legacy system that will be obsolete by next year. But how is a model 1/50th the size actually competing with a frontier giant? I will show you the exact benchmark breakdown that flipped the industry upside down. Transitioning to a 3B-centric architecture isn't just a technical swap, it's a fundamental business decision. In the 2026 landscape, the choice between local execution and cloud inference defines your product's unit economics. You need a framework to decide. Does this task require the massive knowledge base of a 400B model, or just the refined reasoning steps of a 3B model trained with GRPO? Most enterprise workflows think automated PE masking, local code refactoring, or real-time diagnostic reasoning actually thrive on the low latency of on-device AI. We're talking sub-50 ms token generation on consumer-grade hardware. By the end of this session, you'll be able to audit your existing model stack and identify exactly where to cut the cord from expensive frontier APIs without sacrificing accuracy. The scale myth is dead, and efficiency is the new king of the AI world. But is this high performance consistent across all languages, specifically for complex Korean business contexts? The answer involves a surprising twist in how we handle tokenization, which we will explore next. The AI industry is currently facing a silent crisis, the failure of the scaling law to provide linear returns on investment. For years, the industry operated under the assumption that more parameters and more compute would naturally lead to higher intelligence. However, as we moved from GPT-3P5 to GPT-4 and beyond to the massive trillion parameter clusters of 2025, the cost of training and inference began to grow exponentially while performance gains in reasoning started to plateau. Startups are finding that high-end GPU costs for running these frontier models are eating their entire margins. We have reached a point where the carbon footprint and financial overhead of a 1 trillion parameter model can no longer be justified for 90% of business tasks. This inference wall is forcing architects to reconsider the value of every single parameter in their stack. We are seeing a shift where raw scale is being replaced by efficiency as the primary metric of success. But cost is only the first part of this crisis. The second part concerns where your most sensitive data actually lives. 그런데 여기서 문제가 생깁니다. 다음 장면에서 확인하세요. As we move into 2026, the market is aggressively shifting toward private into local intelligence. Sending every internal thought, trace, trade secret, or customer interaction to a centralized cloud API like OpenAI or Anthropic is increasingly seen as a massive security liability. Regulatory frameworks like the EU AI Act and local data sovereignty laws are making on-premise or on-device processing a mandatory requirement rather than a luxury. For a Korean enterprise developer, this means finding a way to run reasoning-heavy agents on local NPU-equipped laptops or private edge servers without losing the logical depth of a frontier model. The cloud-first era is ending because it cannot solve the privacy latency trade-off required for real-time, high-stakes decision-making. We need models that are small enough to fit in a pocket, but smart enough to solve complex logical puzzles. This shift is creating a massive vacuum that massive frontier models simply cannot fill. 이 방식이 항상 옳을까요? 판례를 바로 보여드리겠습니다. The industry consensus is now clear. Model bloat is the enemy of deployment. When you try to force a massive model into a production environment, you encounter massive RAM bottlenecks that lead to heavy 4-bit or even 2-bit quantization. While these techniques reduce size, they often destroy the fragile reasoning chains required for coding or complex planning. We are seeing high-performance inference engines struggling to keep up with the sheer memory bandwidth required by these giants. Engineers are realizing that a bloated general-purpose model is often slower and dumber in practice than a highly specialized small model when running on constrained hardware. This realization has sparked the SLM or small language model revolution. Industry leaders are warning that the current path of building ever larger models is unsustainable for the global economy. 지금까지가 이론입니다. 실제 코드에서는 전혀 다른 일이 벌어집니다. How did we get to the VibeThinker 3B? It all started with a lineage of reasoning models like DeepSeek R1. These models proved that if you focus on the chain of thought and verifiable reinforcement learning, a model can develop deep logic without needing a massive knowledge base. VibeThinker 3B takes this a step further by using GRPO group relative policy optimization. Unlike traditional PPO, GRPO eliminates the need for a separate value or critic model during the training phase, making the alignment process much more efficient for small architectures. This allowed researchers to pack opus-level logic into a tiny 3 billion parameter shell. This isn't just about distilling answers. It's about distilling the PRPO process, PRPO of thought. We are seeing a genealogical shift from general-purpose parrots to specialized logical thinkers. But how does a mere 3 billion parameters hold the same weight as a trillion-parameter giant? 다음 장면에서 핵심 원리를 공개합니다. The secret to this incredible performance is a combination of parameter efficiency and logic distillation. Instead of wasting billions of parameters on memorizing historical dates or celebrity trivia, which can easily be fetched via RARAG, the 3B model's entire parameter budget is dedicated to logical operations. We use supervised fine-tuning on synthetic data generated by 100 trillion parameter teacher models, but we don't just ask for the final answer. We distill the entire self-correction and verification loop. This creates a model that knows how to think, even if it doesn't know every fact. In 2026, this compressed logic approach allows a 3B model to perform as well as a 2024-era frontier model in coding and mathematical reasoning while being small enough to run on a standard smartphone or a basic workstation. This is the ultimate reversal. Your massive model is slow and dumb because it's carrying the weight of the whole world, while the 3B model is agile and sharp. To understand how this tiny footprint achieves such depth, we must examine the architecture of compressed logic in the next chapter. 지금 바로 넘어가시죠. In the world of 2026, we no longer assume that massive parameter counts are the only path to intelligence. The VibeThinker 3B model proves this by starting with a radically different supervised fine-tuning or SFT approach. Instead of just learning to predict the next token, this model is trained on dense chain of thought datasets. We aren't just giving it the answer, we are feeding it the entire logical derivation. This primes the model's weights to internalize step-by-step reasoning as a fundamental behavior rather than an emergent one. In professional environments, we see that this high-quality priming allows a 3B model to follow complex instructions that previously required 7DB models. By focusing on the logic path during SFT, we build a foundation where the model understands the why before the what. Question: does shrinking the model mean we lose the logic, or can we bake it into the foundation more efficiently? The secret to making a 3B model think like a giant lies in the data mixture. For VibeThinker, we use a curated stack of synthetic data generated by frontier models combined with high-quality textbooks and logic puzzles. This synthetic-to-real ratio is carefully balanced to prevent model collapse while maximizing reasoning density. In 2026, the industry has shifted away from more data to better data. We use specific datasets that emphasize mathematical proofs and coding logic because these structures are the hardest for small models to hallucinate. When a 3B model is trained on this dense logic stack, its latent space becomes more organized, allowing it to retrieve and connect concepts with surprising precision. Teaser data is the fuel, but the engine architecture matters even more. Let's look at the specific problem of language nuance. Reasoning in Korean presents a unique challenge for small models due to tokenization efficiency and the scarcity of high-quality reasoning traces compared to English. For VibeThinker 3B, we implemented a dual-stage tuning process. First, we align the model's core logic in English, the universal language of math, and then we map that reasoning capability onto Korean linguistic structures. This prevents the translation lag where a model thinks in English and translates to Korean, which often degrades logic. By using specialized Korean synthetic reasoning sets, we ensure that the model maintains Opus-level performance in local business contexts, such as analyzing Korean tax laws or complex corporate hierarchies. This localized reasoning is what makes on-device AI actually useful in the Korean market. Payoff Korean reasoning is the final boss for global models, but wait until you see the reinforcement learning trick that solves it. Traditional reinforcement learning like PPO requires a critic model, which essentially doubles the memory overhead during training. For a 3B model targeting on-device efficiency, this is a deal breaker. Enter GRPO, or Group Relative Policy Optimization. Instead of a separate critic, GRPO evaluates a group of model outputs against each other. It calculates the relative advantage within that group, significantly reducing the VRAM required. This architectural breakthrough allows us to perform intensive reinforcement learning on much humbler hardware. By eliminating the critic, we focus all our compute on the actor, the model itself, enabling it to explore much more complex reasoning paths during training without hitting a memory wall. Question: if there's no critic model, how does the model know when it's lying to itself? The magic of GRPO is the feedback loop it creates for self-correction. During training, VibeThinker generates multiple attempts for the same reasoning problem. Some attempts are messy, while others are structured. The reward model doesn't just look at the final answer, it rewards the model for the clarity and accuracy of its internal steps. This forces the model to realize, wait, step 2 was wrong, let me restart. This self-correction capability is what separates 2026 small models from their predecessors. We are essentially teaching the 3B model to be its own judge, allowing it to navigate through multi-step logic without drifting into hallucinations. Teasers or self-correction is powerful, but it needs a tangible goal, especially when dealing with hard logic like code or math. To ensure VibeThinker's reasoning is grounded in reality, we use verifiable rewards in math and code. Unlike creative writing, math has a ground truth. If the model is asked to solve a Python function, the reward model can actually run the code to see if it passes unit tests. This creates a hard, objective signal for the GRPO process. When the model passes a test, it gets a massive boost. If the code fails, it's penalized. This creates a highly capable 3B model that doesn't just look like it's coding, but actually understands the execution logic. In the industry, we call this symbolic grounding, and it's the bridge that lets a small model achieve opus-level accuracy in technical tasks. Payoff verification works for math, but how do we scale this training without needing a server farm? The efficiency gains of GRPO are staggering when we look at the numbers. By removing the critic and reference models from the VRAM footprint during certain training phases, we can fit larger batch sizes or longer sequence lengths on the same hardware. This means a 3B model can be trained to handle 32K or even 128K in text windows for reasoning, which was previously impossible on standard professional GPUs. For startup teams in Korea, this democratizes high-level reasoning training. You no longer need a massive cluster to build a model that thinks like a frontier model. VibeThinker 3B is the result of this optimization, delivering elite performance with a fraction of the energy and hardware costs. Question: training efficiency is great, but can this logic actually run on the device in your pocket right now? To get VibeThinker 3BB running at 50+ tokens per second on a smartphone, we have to talk about the last mile of optimization, quantization, and NPU acceleration. In 2026, 4-bit weights are the standard, but we've moved to importance-aware quantization. We keep the reasoning critical weights at higher precision while compressing the rest. This is layered on top of NPU-specific kernels that bypass the CPU entirely. By using 4-bit NT4 quantization specifically optimized for the latest mobile chips, the model's memory footprint drops to under 2 GB. This leaves plenty of room for other apps, making the AI feel like a native part of the OS rather than a heavy background process. This is how we move from cloud AI to truly personal AI. Teaser speed is one thing, but memory is the real killer for on-device AI. Let's look at the cold, hard numbers. Let's look at the operational reality. Running a 3B reasoning model on a smartphone with batch size 1, typical user scenario requires extreme VRAM discipline. At NT4 precision, VibeThinker 3B consumes roughly 1.8 GB of VRAM. This is revolutionary compared to 2024, where even small models struggled with context memory. With advanced KV cache compression, we can handle long conversations without the phone heating up or killing the process. For developers, this means you can finally deploy reasoning capabilities, not just chat directly to the edge. Whether it's a field engineer in a remote area or a CEO reviewing private documents on a flight, the model works without a single byte leaving the device. For Bridge to 4, we've seen the architecture, but is it just a theoretical win? In the next chapter, performance reality check. We will put VibeThinker 3B head-to-head against the giants to see if it actually holds up in production. In the AI industry, we often see benchmarks that look too good to be true. However, the VibeThinker 3B model is forcing us to redefine what is possible for small-scale architectures. When looking at MMLU and GSMAK results, this 3B parameter model is consistently hitting scores that were exclusively held by frontier models like GPT-4 or Claude 3.5 Opus just a year ago. The secret isn't just raw data volume. It is the reasoning density achieved through Group Relative Policy Optimization, or GRPO. While a 1 trillion parameter model has a massive library of general knowledge, VibeThinker 3B focuses its entire brain on the logic of the problem-solving process itself. In many specialized coding and math tasks, the performance gap has effectively closed to within a 3 to 5% margin. This represents a massive shift for on-device AI implementation, where we can now run Opus-level logic without a data center. But does this raw score translate to every task? The answer is more complex than a single table suggests. We need to look deeper into where the small model starts to crack under pressure. But wait until you see where these benchmarks actually fail to tell the whole story. Despite the impressive benchmarks, we must be realistic about the trade-offs inherent in a 3 billion parameter model. The most significant limitation is world knowledge depth. A model like Claude 3.5 Opus has a massive internal memory for niche historical facts, legal precedents, and obscure medical data. In contrast, VibeThinker 3B is a reasoning engine, not a knowledge encyclopedia. When pushed into long context scenarios exceeding 32K tokens, you will start to see a decline in retrieval accuracy compared to the massive models. Hallucinations in a 3B model often look different. It might follow the logic perfectly, but hallucinate a specific fact it simply doesn't have the capacity to store. Furthermore, the KV cache on-device is limited, meaning while the model is fast, its short-term memory during a long conversation can be a bottleneck. For developers, this means RAG retrieval augmented generation is not optional for VibeThinker. It is a mandatory architecture component to supplement the model's limited internal storage. Understanding these boundaries is what separates a successful AI product from a failed experiment. Is this model a replacement for everything? Absolutely not, and I'll show you exactly where it hits the wall in professional environments. For those of us working in the Korean market, the true test is linguistic and cultural reasoning. Korean is a high-context language where subjects are often omitted and honorifics change the entire structure of a sentence. In the past, small models often failed here, sounding like a translated manual. However, the VibeThinker 3B variant for 2026 has been specifically fine-tuned with Korean-centric chain-of-thought data. It doesn't just translate, It reasons through the social hierarchy and intent of a Korean business request. For example, if you ask it to draft a sensitive email to a senior partner, it understands the nuance of Gongsunham politeness, while maintaining the logical core of the message. This cultural reasoning is a breakthrough for on-device AI in Korea. It allows local applications to run securely on a smartphone while feeling natively Korean, rather than a filtered American AI. We've observed that in social logic tests, it outperforms much larger models that lack this specific SFT focus. But how does the developer community actually feel about these claims? We looked at the latest independent reviews to see the ground truth. The verdict from the community, especially on platforms like Geek News and local developer forums, has been surprisingly pragmatic. The consensus among AI architects is that VibeThinker 3B is the first sub-Team B model that can actually be trusted with autonomous tasks. Independent verifications show that while it might not write a novel, it is in a light logic controller. Developers are reporting that for 80% of enterprise microtasks like data extraction, API routing, and sentiment analysis, this model provides 95% of the value of an Opus class model at a fraction of the cost and latency. The independent blind tests conducted by community members show that users often cannot tell the difference between this and GPT-4 for short-form reasoning tasks. This is the performance reality of 2026. We are no longer chasing parameter counts. We are chasing utility per watt. This concludes our performance audit. Now that we know it works, the question changes from is it good to how do we actually deploy this in a production environment. In the next chapter, we will build your strategic adoption framework. In 2026, the strategic question is no longer can we use AI, but where should the reasoning reside? With the emergence of VibeThinker 3B, we are seeing a fundamental shift where small, specialized models achieve what we once called Opus-level performance for specific logical tasks. For a decision architect, the flow starts with assessing data sensitivity and latency requirements. If your application requires real-time logical branching such as an autonomous agent or a privacy-first assistant, local deployment is the only way to avoid the cloud tax and latency jitter. While cloud models still hold the crown for massive world knowledge retrieval, we must map out a hybrid architecture where the 3B model handles high-frequency logical thinking locally. But how do the finances of this architectural split actually look over a multi-year horizon? This leads us to a critical financial realization regarding the true cost of intelligence. Total cost of ownership is where most enterprise AI projects fail. While cloud API providers constantly lower their token prices, the volume of reasoning-heavy chains where a model thinks through multiple steps can lead to exponential billing. With a model like VibeThinker 3B optimized via GRPO, the initial investment shifts from recurring OPEX to controllable CAPEX. Over a 3-year period, maintaining a fleet of on-device AI units or localized edge servers often results in a 60 to 70% reduction in cost compared to high-tier cloud reasoning APIs. You aren't just paying for the hardware, you're buying independence from provider-side latency spikes and sudden model version drift. Yet, hardware costs aren't the only hurdle to clear in your roadmap. The real challenge often lies in how we integrate these small weights into existing pipelines. Is there a standard way to manage these local powerhouses? Let's look at the implementation roadmap. Integrating a reasoning-capable small model requires a specialized roadmap. We don't just swap a cloud endpoint for a local file. It begins with the MVP phase, where we define the specific reasoning domain, perhaps it's code generation or medical triaging, where VibeThinker 3B's SFT and GRPO training shines. From there, we move into model governance. In this stage, versioning isn't just about code. It's about tracking how different quantization levels impact logical consistency. You need a robust CI/CD pipeline that treats the model weights as a living artifact, testing them against reasoning benchmarks every time the environment changes. This systematic approach ensures that as your on-device fleet grows, your intelligence doesn't fragment across different hardware versions. But as we decentralize this intelligence, we open up a new front of vulnerability. How do we ensure these local models aren't leaking the very data they were meant to protect? This brings us to the final compliance checklist. Deploying local reasoning models is often driven by a need for data sovereignty, but local does not automatically mean secure. In our 2026 landscape, we must audit the entire inference stack. This includes securing the weights themselves and preventing prompt injection at the edge. Our checklist starts with ensuring strict PA filtering happens before data even touches the local inference engine. We then look at inference isolation, ensuring the AI process cannot access sensitive system memory. Finally, we must establish a clear update protocol. How do we patch a model that is distributed across 10,000 local devices? Addressing these security pillars allows us to leverage the power of VibeThinker 3B without compromising the trust of our users. Now that we have the framework for adoption and the shield for security, it is time to look at the final piece. Your mandate as an AI architect in this new era of efficient intelligence. What is the ultimate takeaway for your organization? As we head toward 2026, the industry is witnessing a massive correction. The obsession with parameter counts is being replaced by a focus on reasoning density. We have explored how a 3B model, when refined through SFT and group relative policy optimization (GRPO), can effectively punch in the same weight class as Opus-level models for specific logical tasks. This isn't just about saving on cloud costs. It's about the fundamental shift toward on-device AI where latency and privacy are non-negotiable. If your architecture still relies on a 1 trillion parameter behemoth for tasks that require simple sequential logic, you are carrying a legacy burden that will slow your product's evolution. The 3B VibeThinker style models prove that with the right reinforcement learning strategy, small models can exhibit the chain of depth previously thought to be an emergent property of only the largest systems. The evidence is clear. Efficiency is the new intelligence. But does this mean we can simply replace every large model tomorrow? Not quite, because the real challenge lies in how we manage these specialized thinkers. This concludes our deep dive into why smaller reasoning models are winning the race, but your journey as an architect is just beginning. The next frontier isn't just the model itself, but the agentic workflow it powers. In our upcoming Local LM series, we will transition from looking at models as static endpoints to seeing them as autonomous agents. We will examine how these 3B thinkers can be orchestrated into swarms, where each model governs a specific domain handling tool use, local data retrieval, and subtask planning without ever touching the public internet. This requires a robust framework for model governance and versioning that most teams haven't even considered yet. We are moving from the era of the generalist monolith to the era of the orchestrated specialist. The goal is to build systems that aren't just fast, but truly autonomous and verifiable. Prepare your infrastructure for this shift, because the ability to deploy Opus-level reasoning at the edge will be the primary differentiator for AI products in the next 24 months. Our next module will tackle exactly how to build these agentic swarms using the very models we discussed today.